Today we're going to be using the iConnect training building simulators. We're going to dive a little bit into the units and then some of the training lessons. Hello everyone, thanks for joining. Today we're going to be working with the BL-01 training simulator. We're going to be working on Lab 3 using the Sedona Application Editor. This can be done through contemporary controls, and you can see the website here at www.ccontrols.com. Once there, you can go to Support, Software Downloads. If you scroll down under Sedona Downloads, you'll see BAS Control Toolset. One thing to note is you will have to register with Contemporary Controls website. It's free to register, and then you can download the software. Once downloaded, it's pretty simple. Double-click, accept the terms, read through the agreement, select where you want to install it, what software you want to install, a couple more options, and then install. So we can finish, and then if you selected the desktop icon feature, you should have 3 icons. The Sedona Application Editor, if you installed it. If you don't have the desktop icons, you may have to check your Start menu, and you can find them there. In this lab, we're going to be connecting to an emulated controller. In the software, we're going to be looking at the different panes. We're going to look at a few different components, and we're actually going to drag some onto a work pane, and then we're going to link those components to form a complete program. So a little about the Sedona Application Editor, also known as SAE. It allows technicians the ability to develop control applications for Sedona devices. It was originally developed by Tritium, and the framework is a software environment designed to make it easy to build smart network embedded devices which are well suited for implementing control applications. So with that, we're going to get into the computer. Like I said, we're running an emulated controller, so we can take the actual controller, disconnect it, and set it to the side. We don't want to get confused between the two. In future labs, we're going to be using the actual controller, but while we're doing some programming and learning the bare bones, it's good to be in that emulated virtual environment. The first step is to start the emulator. So we'll get that running. It should open a browser window, ask for the username and password, and there you can see the emulator is running. And so now we want to open Sedona Application Editor. When you open the software, there's not a whole lot to see. There's the title bar, the menu bar, and the toolbar, and then the welcome screen. So until you connect a controller, this is what you're working with. So to open a connection, there's 2 ways to do it. You can do File, Open Connection, or on the toolbar you can click Open Connection. The nice thing is Sedona usually has the IP addresses already preloaded, and so our emulated version's there, and you can see in the drop down the actual controller IP address is also there. So we're connecting to the emulated controller. We're not changing the port. We can put in the username and password, and that should make the connection. Once the connection's made, it changes significantly. You can see the 4 different windows here. So in the middle is the work pane. To the upper left here is the navigation pane. This is going to be a tree-like structure. One thing to point out is in the upper left here, you can see the IP address of the emulated controller. If you were in a complex or a big building with multiple controllers, you would have different tabs here. Since we only have the 1 emulated controller, we're only seeing the 1 tab in the navigation pane. Here you have the kits pane, and then you have the properties pane to the right. When you first connect to a device, you're going to see these 2 folders, the service folder and the sheets folder. We're going to ignore the service folder for now. Obviously, you never want to delete it. This service folder has a lot of the background tasks that are required to run a functioning Sedona device. So if we open the Sheets folder, we're going to see a blank wire sheet. This is where we're going to be creating a program by using the Kits pane here and dragging components onto the wire sheet. On the bottom left is the Kits pane, and this lists all the available kits that are present and stored on the connected Sedona device. So if you dive through, you can see the different components. We'll be utilizing some of these today, but when you're doing a full programming, you're going to be using a lot more of these. The first thing we're going to do in the work area pane is put down a folder. So this can be found in the syskit. You can see folder, and we're just going to drag it right there. So you can rename components. If we want to rename this folder, we're going to click it, and you can see the red border. And if we come up here in the properties pane, select the name, we can do test 1. And there you can see it's changed on our component. One thing to note is that Sedona only allows you to have up to 7 contiguous characters for naming a component, and you cannot lead with a number or a special character. Upper and lowercase characters are allowed. So if we double click the test folder, again it's going to open a blank wire sheet. So we're going to contract the syskit, and we're going to open the function kit. We're going to find TickTock and drag that onto the wire sheet. And we're also going to drag count onto the wire sheet. So now we have 2 components, and you can see this one's tick-tocking, true, false, true, false. What we want to do on the outside of this, we want to drag and we want to go into the inside of count. And so now we've just linked our 2 components. The out of the TickTock is going to the in of the count. So you can see these are now counting together. So if you look on the component here, each of these is called a slot. So we've linked the out slot to the in slot of count. We're going to contract the function kit, and we're going to open the types kit. We're going to find constant boolean. We're going to drag that onto the wire sheet. If you notice here, in the kits pane, it's labeled const bool, but since we can only use 7 characters, it automatically renamed it on the wire sheet. So now we're going to link the out slot to the enable slot of count. And so you would think that this would start counting now because we've just enabled it. The problem is the enable is still labeled as false. So we're going to have to change that to true. So to do that with this program, we're going to select all 3 of these components. On our properties pane, under constant boolean, we're going to go to the out, and we're going to select that and change it to true. Now when we click out of there, you can see the count is going to start counting. Every tick or every tock is going to be a count. So there you go, we've created our first program. It's a very simple one. We are just counting ticks and tocks, but it gives you the idea that we're linking slots together. We're linking components together. So the out slot of TickTock is going to the in slot of count. Usually the out slot is on the right side and it's going into the left side of the in slot. So now if we go to our navigation pane and we go down in the tree and we open up test, you're going to see the 3 components show up in the navigation pane. So one thing to note is the asterisk here. This means that a change has been made to the program but has not been saved onto the Sedona device. So that's key. You always want to save your work. So one thing to note is that when you're developing an application, you are developing it on a live controller where you can instantaneously see the results. It's very convenient, but it needs to be done with care. If you're on an actual controller that's hooked up to physical equipment such as a boiler or HVAC components, making changes can be a big deal. So that's where the emulator comes in. It's very handy. We can make changes, we can mess around with stuff, and we're not going to potentially screw up an actual controller. So before we save the program, let's rename it. So we're going to do that by going to Tools, App Configuration. Let's change device name to My Device. The app name to My First App. The scan period, 200 milliseconds. We're just going to leave that as is. Essentially, 200 milliseconds means that a logic is solved 5 times a second. So let's apply that. You can see the changes here. App, My Device, my device, and then over here you can see my first app. The other way you can see the changes is if you go to the navigation pane and click on the app, and here you can see device name, my device, app name, my first app, and then the scan period in the property pane over here. So now we want to save to the controller. Again, there's two ways to do this. On the toolbar, save to controller with the lightning bolt looking icon, or you can go File, Save to Controller. Success, the app was saved successfully, and now you can see the asterisk disappeared that was next to the app folder here. The other thing you can do with an emulated controller is you can save to the PC. So you see this monitor with the down button, save to PC. You can name this My First App. And then it's saved to the PC successfully. Now let's do a quick test. If we drag the cursor and highlight all these, and then click delete, now we have a blank wire sheet. If we were to close the controller and reopen, our program would still be there because we haven't saved it, right? But yeah, let's say you made the mistake and you deleted something and you want to restart from where you were. We can load from PC, select My First App, once it loads, our program should be back in place. We'll go in the Sheets, the Test, and there it is. So there you have it, Lab 3 complete. It was a pretty short one. We got into Sedona Application Editor. We created a very simple program, but we got to see the different kits. We got to see some of the different functions. We got to see some of the different components. This was great to do in an emulator because, again, it was a virtual environment. There's no risk of potentially messing up an actual controller. The emulator is good, right? It gives you a feel, but to work on an actual controller takes it to the next step. Using the BL-01 controller, we know that we're not going to ruin a boiler if we mess something up. We know that we can restore the default settings if we go a little too deep or a little too far. So I definitely recommend using one of the training simulators. In the next lab, we're actually going to be working with the actual controller again, so that's going to be cool. In Lab 4, we're going to be utilizing the training simulator again. We're going to connect to the actual controller, and we're going to be creating another program. It's going to be a basic binary and analog program. Again, we're going to be using components, dragging them onto the wire sheets, linking them together, and then testing the program. So again, I want to thank iConnect Training. The training seminar that I've been following along with is a great step-by-step introduction into building automation systems. The training simulators that they have are awesome. The BL-01, the bare bones, what we've been working with, is a super easy introduction into building automation systems. If you check out their website, iConnectTraining.com, there's a couple different simulators on there. Right now I think there's 4 training simulators for building automation systems, but they have a whole slew of training equipment for the HVAC industry. So check out the website. Again, iConnectTraining.com. Thanks for watching.